Hello everybody, my name is Miroslav Stampar. I'm coming from Croatia and I would like to present you, I would say, a work I've been doing for more than 10 years. So I'm one of co-authors of the SQLMAP, so I will try to present some, I would say, internals in this short period of time. So as an introduction, what is a SQL injection? So you have a vulnerable code with some SQL statement, and if the web application, the other end, is just concatenating it into this same statement without any kind of filtering or escaping, you will have the SQL injection. And this is the formal definition, but I would say in plain speak, any kind of unauthorized DBMS access by using this kind of injection by the user is called SQL injection. Techniques. So these are the foundation of the SQLMAP and the SQL injection. So I'll present you the 5 most important SQL injection techniques. So first one is the basic one called Boolean-based blind. So you're trying to force the web application to execute some kind of Boolean expressions at the other end, and you're trying to see whether there will be changes in the reply from the other end. So in case that this same statement, this Boolean statement, is evaluated as true, you will see the same response as the original web page. But if this same subquery is evaluated as false, you will see some kind of difference at the other end. Problems with this same technique, it's slow, so you need 1 request per bit. There is one slower than this one at the other slide. It's based on the page differentiation, so you are trying to see the differences inside the responses compared to the original page. In case of law of difference or delta ratio, so if there is no difference compared to the original, you can infer or conclude that it's about the true response. In case of a huge difference, it will be a false response. Error-based SQL injection technique, you're trying to provoke the DBMS error at the other end, and by using this same DBMS error, you can provoke the other end to include the result of some subquery inside that same error message. So by using the error messages, you can do fast queries and responses by using this same principle by, I would say, analyzing the error messages from the other end. Union-based, you're trying to inject the union statement into the injectable SQL statement at the other end. And this one is considered as the fastest because you can do a 1 subquery here inside the union this appendix, and you can get a full table dump in 1 single request. So just by comparing these 3, this one is the fastest, then you have the error-based, which is the second one, and the Boolean-based is this third one. And now you have the, I would say, the slower ones. So time-based blind is pretty much similar to the Boolean-based blind, but instead of comparing the page responses, or I would say content of the response, you're comparing the differences in the network response times. So if there is a huge delay from the other end, you can conclude that you provoked some kind of deliberate delay, and that same statement was evaluated as true. In case that this same statement is evaluated as false, there won't be any kind of deliberate delay in the response. So by just comparing the response times, and if you see that there is no delay, you can conclude that your same, I would say, SQL injection that had this kind of payload inside evaluated as false. So in this case, this should be evaluated as true, and if it is evaluated as true, you'll get some kind of deliberate delay. So in this case, there will be some kind of a batch of MD5, so some dummy string, which will cause some deliberate delay at the other end. It's slow, so you need 1 bit per request. So I would say 1 request per bit, and each true response will make some kind of delay. So you can imagine if you are dumping huge dumps with huge tables, you'll need for sure to wait for maybe 30 minutes or more. There is also something called stacking. So this stacking can be used for table dump retrieval, but also it can be used for non-select statement evaluation. So if you need to evaluate some kind of insert, delete, update, or stuff like that, so which is not strictly query-based, you will need some kind of stacking. So this stacking, this is I would say, the most important part of it. So you have this character here, which says, okay, stop this original SQL statement here, which is being evaluated by the other end, and just append some kind of insert here. So in this case, that original statement would evaluate some kind of select from the users, and this stacking would do some kind of insertion. This same principle is affecting mainly the mix of SQL Server and the Postgres platform. So in case of popular MySQL or Oracle, you won't be able to do this kind of stuff. This is a mandatory for if you want to do any kind of data modification at the other end. So if this stacking is not recognized by the SQLMAP, you won't be able to do any kind of tampering of the data at the other end. There are also some other techniques which I won't go into details here, but just to let you know that there is something called DNS exfiltration. So you can use DNS responses, and by mimicking the DNS server, SQLMAP can play, I would say, the DNS request and response, and by using the extraction of data from the DNS responses from the other end, it can exfiltrate the data from the DBMS server. There is something called lateral and second-order attacks. I won't go into details. And now the SQLMAP, what is it all about? So this is the general introduction into the SQLMAP. So it's free and open source software. It's 16 years old, so it's pretty, I would say, mature. There are 2 authors, developers. One is Bernard Damel and myself. We coded lots of Python and XML inside. So Python is basically all the workflow is done in Python, and all the payloads, or I would say the knowledge base, is being done inside the XML. So if you would go to the SQLMAP page at the GitHub, you will see lots and lots of XML files. So for example, if you are a pen tester and you would like to know what is SQLMAP trying to do inside its workflow, instead of, I would say, coping with this Python, you can immediately go to the XML and maybe learn some stuff, I would say. For example, if you need a query for dumping of users on the Oracle database management server, and you need to do it manually, just go to our knowledge base and, I would say, learn stuff. Lots of commits, resolve issues, and we have a pretty good, I would say, accuracy. So we are proud that SQLMAP will rarely get stuck to the false positives. So we have a really good engine for detection of the false positives, and I will show you what we do and how we try to detect the false positives. Capabilities, so lots of switches, options. So in 16 years, there were lots of user requests. I stated there are lots of resolved issues. So each of those issues are some sort of user request. So we try to, I would say, fulfill them. Lots of switches options, full coverage for 37 relational database management systems. This is important to mention here. So we are covering relational database management systems, not NoSQL stuff. So NoSQL is not SQL. So there are lots of, I would say, pings toward our side to implement other stuff than the relational database management systems, but that other stuff is totally different. So NoSQL has nothing to do with the SQL, and that would require a totally, I would say, separate tool. So we decided to not implement it. But we implemented huge, I would say, knowledge base for 37 different database management systems, full support for all those techniques I've shown you. And after SQLMAP is able to detect any of those techniques, it will provide you with the capability to do this full database enumeration. So if you want to do database dumps, user base dumps, if you want to retrieve password hashes, do cracking of the password hashes in an automated way by the SQLMAP, it will do everything for you automatically. It also provides you with the means for doing the file system manipulation. So you can try, I mean, lately it's not so possible like 10 years ago, but you can try to exfiltrate the content of the operating system file system stuff. So you can try to steal files with the SQLMAP. Lately, it's database management systems are getting better and better, so this kind of stuff is, I would say, a relic. Also, there is a possibility to do the out-of-band communication like that DNS exfiltration I mentioned. Now, a sample run. So you go to the GitHub pages, you download SQLMAP, install Python, and you're ready. And you have your web page with some parameter. So this is a dummy web page from the Acunetics. We like to use it because it's free and open to all. And you can immediately start to, I would say, test the SQLMAP without doing any kind of illegal stuff. So this is the legal way how to, I would say, tune your SQLMAP capabilities or try the SQLMAP what it does. Once you run it, so you provide the URL, SQLMAP will show you some logs, and everything which is bold is important. So in this case, important stuff here is that there is some kind of error provoked at the other end, and SQLMAP detected, okay, this seems to be injectable because there was some MySQL database error. It says, okay, do you want me to skip other payloads which are specific for all those 36 other database management systems? If you say yes, it will just focus on the MySQL and try its best to exploit it in the best possible way, in least possible requests done. Okay, now this is the first technique that it's successfully found. So Boolean-based blind on this same parameter artist. So here. Afterwards, once it finishes that initial run, you are being presented with this kind of, I would say, table. So this is the popular, I would say, console output that's all those bug bounters like to put into their reports. So if you have this kind of, this segment here, and you put into your bug bounty reports, be sure that you could get some money in return. Because in these 16 years, as said, we paid close attention that we reduce false positives to near zero. So if you get this and you're owner of the web application, you can be worried. Now, some of those internals. So we'll use lots of heuristics. So heuristics are fast techniques that give you capability to skip all those tests that the SQLMAP can do, and it can reduce and focus on the, I would say, the most important stuff. So for start, if we try to to deliberately provoke the errors with this kind of erroneous values. And if you get this kind of SQL errors at the other end, and we detect that this is, in this case, MySQL, we will narrow down the tests only to the MySQL. Also, we will automatically extend those same tests to the MySQL. So there, when you run the SQLMAP with default options and switches, you will get the, I would say, the tuned version of the SQLMAP, where you won't run, for example, tens of thousands requests per each parameter. We really tune down to the most important stuff if you are, I would say, a basic user. But SQLMAP automatically says, okay, we will try to help you as a user. You don't need to know all those hundreds of options and switches. If we detect some stuff with the heuristics, we'll try to help you and further extend those tests and focus on important stuff. How does it look in one test run? So you can see this payload was being sent instead of that original one. So we deliberately put here some junk, especially pay attention to this single quote, double quotes, and we provoke the error at the other end. And SQLMAP said, okay, this could be MySQL. Later on, this is just the, I would say, the bonus. So we also try to provoke, I would say, in those same errors, some kind of response that could show you that maybe there is some cross-site scripting going on at the other end. So this is, SQLMAP is not the web application scanner, it is really a specific SQL injection tool. So it's specialized only for the SQL injection, but here we said, okay, let the users run this single request and maybe they could, I would say, get some cross-site scripting. I mean, if they are running all those tests against the huge web applications, maybe we could help with this single request and say, okay, maybe there is cross-site scripting there. We won't be able to, I would say, to exploit it, but maybe you can take a look by your own. Later on, I will show you also there is something called levels and risks. So as said, if we detect that there is a specific DBMS at the other end, we'll give you a possibility to further focus on those same DBMSs. Now, imagine the situation that the error messages are turned off, and we will really like to use some kind of heuristics and fasten the whole testing. So, especially, I would say, juicy cases are the integer ones, where you can put this kind of stuff instead of the original values. So have the ID equals 1, and you send some arithmetic equation to the other end, and if this is evaluated to the 1, while we detected that this is changing with different values, we say, okay, this could be SQL injection. And why I said that? Because in all those 16 years, we tested lots and lots of different stuff, and SQL itself is one of rare languages at the web application arena, which will actually evaluate this to some value here. So if you can evaluate basic arithmetics like this, or for example, you put here 1 multiply 1 or 2 multiply 1 or 42, and this same is being evaluated by the other end with the same response as the original value, you can be, I would say, pretty sure that there is some kind of SQL injection at the other end. So this helps us in cases that the error messages are turned off. Also, one really, I would say, important thing is that we warn the users in these kind of cases that this is most probably prone to SQL injection attacks. And if SQLMAP fails for whatever reason, for example, there is some kind of firewall at the other end, cool thing is that this won't be detected by the firewalls as SQL injection, because this is a dummy minus operation. But we say with, I would say, certain probability, if SQLMAP fails, you should really try to poke around manually, because we are, I would say, pretty confident that could be a SQL injection in the other end. So we are making user aware to persist in their, I would say, testing, either manually or try to use the higher values for the level risk, or use the specialized Stampar scripts. Stampar scripts are special scripts which are modified in the payloads which are being sent to the SQL, to the other ends, which are trying to mask the content of the SQL injection itself. So it tries to fool the firewalls by using some, I would say, specifics of the database management systems at the other end. For example, imagine some strange encoding which only the database management system can decode, but the firewall itself is not specialized in the SQL stuff. It is specialized in detection of the attacks. So we try to I would say, collect all those techniques inside of those specialized scripts, and we try to provide the users the capability to bypass those firewalls. Now, to show you how it looks like, so this is this same operation I mentioned, that arithmetics, and SQLMAP says, okay, this might be injectable. And if, as said, if SQLMAP fails at the end, it will show you one warning box. Okay, maybe you should really try, I would say, harder to further exploit it, either with the SQLMAP or manual. So, as said, those same arithmetics are used when the error reporting is turned off. Also, there is one, I would say, further heuristics being used afterwards, where we are trying to find the DBMS at the other end with a single request. So I'll just go here to show you what I mean. So imagine that the SQLMAP found the Boolean-based blind injection. There were no errors at the other end, and we don't know what the DBMS is at the other end. So we know there is SQL injection. We don't know whether it is MySQL, Oracle, Postgres, or stuff like that. So once the Boolean-based blind is found, we send this kind of, I would say, battery of tests, where each of those payloads are specific for the database management system. So, for example, here we have the quarter null is null. I believe this is MySQL, and only MySQL will be able to evaluate this to true. Difference null is null. This will be evaluated only by the Postgres as the true. So if any of these are evaluated as true, we will know for sure that, okay, this case, this is the, I don't recall what was the DBMS name in this case, but for example, this one is for sure Microsoft Access. So if this is evaluated as true, we'll say, okay, that's most probably Microsoft Access. Do you want us to focus only on the Microsoft Access? So in this case, this one was evaluated true. It says, okay, this could be MySQL. Do you want to only focus on the MySQL here? Now, boundaries, levels, and risks. So as said, there are lots and lots of non-default stuff involved into the SQLMAP. So if you really want to do the, I would say, hard testing of the application, you can play around with this risk and level options. Things that we have hidden that from the basic user, because in majority of cases you won't need to use this kind of stuff. But let's say that you need to do. So there are lots of these kind of payloads inside of SQLMAP's knowledge base. So this is the basic one for the Boolean-based blind. So you have the end, integer equals integer. So these are called payloads. But also you have something called boundaries. So in some cases, you will need to use special boundaries like this single quote space, and afterwards you will need to use this kind of suffix. So all those special cases are hidden inside the SQLMAP, inside the knowledge base, and if you increase this same level, it will try to use as much I would say, of those boundary values as known to us, which could provoke the SQL injection at the other end. So in default cases, we'll try to use only the simplest boundaries, but in those, I would say, higher level values, we try to use also the exotic ones. Also, there is something called risk. There is one anecdote, and I said to myself that I won't go into anecdotes, but I like to say anecdotes. So a couple of days ago, a friend of mine from Ukraine sent me a link to one Russian site, and there was the FSB trial, and guy went into jail because he automated everything from the SQLMAP into one executable, and they said, okay, you're doing a crime. And he was like, that's free and open source software. I don't have anything to do with it. I just made an executable. And now one funny thing, that's the anecdote. They said, okay, man, you used higher risk than the default. So default one is 1. So in default case, there won't be, I would say, much risk. But if you do minus risk, for example, 3, you will use this kind of, I would say, probably dangerous payloads, because if at the other end you have some delete, updates statement, and if you include this kind of payload, you could potentially drop everything. You can delete everything because you didn't know that inside this, inside the vulnerable condition, you included everything with this for true statement. And I said, okay, your default value was minus risk 3. Also, the author said you should not use that by default, and he went to jail. That's the end. So don't use high risk levels, especially if you're not the owner of the web application that you are testing. Now, just to show you the high risk, high level values, what are doing. So in that minus level equals 1, that's the default value, you could probably be left with these boundaries. So you have some parentheses, 2 parentheses, 3 parentheses, some spaces and stuff. But later on, you can end with some, I would say, exotic boundaries, like there's that apostrophe here. So this is not a common stuff that can be found inside the vulnerable SQL statements. Also, you will have some like-alike statements like this, or this exotic stuff. So this exotic stuff, in majority of cases, won't work, but as said, you have the capability, if you increase this same level, to use also those, I would say, exotic stuff. But you should be warned that the total number of requests will grow exponentially. So from, for example, a couple of hundred requests, you can end in 50,000 requests per one single parameter value. And I don't advise you to do that. False positive detection. As said, this is something we are proud of, really proud of. And we are dealing with lots and lots of user requests, and they are saying, okay, I had a true positive from the burp, and I'm like, don't mention me the burp, because burp does not have the proper false positive detection. If they detect that there is some kind of delay at the other end, it will say, okay, you have the SQL injection, and that's it. But we really try our best to reduce the false positives. So if SQLMAP detects that there's something is SQL injection, it will make sure that it is a true positive and that it is exploitable. So what we do, especially in case of Boolean-based blind and time-based blind cases, because those are most prone to the false positive detections, we use lots of simple predetermined Boolean operations. And I will show you what I mean. So imagine that the SQLMAP found a Boolean-based blind injection, and you try to poke the other end with these simple statements like this. So in this case, we send to the other end, okay, please evaluate me this same condition. And if it's evaluated as true, we say, okay, strike one, that's okay. Then later on, if this one is evaluated as false, as expected, we go on. Okay, that's okay. This one should be evaluated as false. This one should be evaluated as true. So it's like a quiz to the other end, like the Turing quiz. Now there is also one special case like this. You can see this. There are lots of user, I would say, issue raised that maybe this is the error in the SQLMAP and this is not the error. So in this case, we are deliberately trying to poke the other end to see what will be the response. So in this case, okay, the database management system correctly evaluated this to true, false, false, true. But in this case, if this is not evaluated as, for example, as false or some error condition, we'll say, okay, there's something is fishy going on because this should be an error nose state. So just to I would say further go into the details, why are we doing that? Because in some cases, the web applications are filtering these kind of symbols. And if you are not doing this kind of, I would say, special error, I would say, condition, you could end up with something that appears to be like a true positive, while it is just a result of the web application filtering. So just imagine that this is being filtered, and the web application semi-correctly says, okay, this is true, true, false, false, and in this case, it will most probably fail. It must fail. It must fail. Now, this is case when this was being evaluated as true, and we said, okay, this was okay, but this is fishy. Okay, this is either false positive or an exploitable detection point. Move along. Delay detection. So previously we did same stuff as other tools. So you want to detect if there is a success in the time-based Boolean condition being sent to the other end. So for example, you try to deliberately delay the other end for 5 seconds. And most tools, I would say 99.99% of tools, that really trying to just compare the expected response with the response itself. So if the expected response was 5 seconds because you tried to provoke the delay at the other end for 5 seconds, and the other end resulted with the 5.5, for example, seconds delay. For example, Burp will say, okay, that's true positive, that's the SQL injection. And now the problem is what to do if there is a huge delay by, I would say, by default inside the web application. So you have the either slow web application, you have the huge network latency, what to do in those kind of cases. So also there are cases with this kind of benchmarks, so we don't know what will be the final result of this kind of delay. This is called heavy query. So maybe this will result with the 1 second delay, 2 second delay. So we figured out, okay, we are thinking what to do, and we figured out maybe we could use some statistics. So we did something like this. So we calculated what's normal and what's not normal. So one SQLMAP is being run, and it comes to the point where it needs to detect whether there is some time-based SQL injection at the other end that is usable. It is trying a priori to do this kind of bell curve. It is calculating what's normal, and it calculates, okay, that's a mean, so that's something that is most expected inside the regular responses, and you have those tails here. So if you go like to this same value, which is easily calculated based on response times, so you have this 7 sigma here. Everything else out, let's say 7 sigma, can be considered as the really a deliberate delay. So you can have a huge latency inside the web application, we just calculate this and we say, okay, this is something that is really out of the normal responses. And how does it look like when you run SQLMAP? So you have here time-based comparison requires larger statistical models. So each of those dots is that one regular request is being sent to the other end. We note the response time. We calculate this same curl, and we note, okay, this is the last point where everything outside of this 7 sigma is really a true positive or really a delivered delay, and everything inside is a regular response. So you can see this, and here are the payloads being sent. So in this case, we tried to deliver the delay for 5 seconds. We got really something that goes outside of that bell curve. That was okay. Here we checked, okay, maybe you could check what you do with non-delay, so sleep 0. So that payload should go inside of that same bell curve. And later on, we just for the case, we try, okay, let us try one more, sleep 5. And if that goes inside that bell curve, we know, okay, that's time-based SQL injection. Now, in case of huge network latency, you can imagine that this same bell curve can be quite big, and they can cause problems to the users, especially during the database retrieval. So we say, okay, there's a huge latency. SQLMAP will try its best to calculate and help you in the detection. But maybe you could also try to fine-tune it with this timesec value. So this timesec value is nothing less or more than you can try to fine-tune this same deliberate delay inside. In majority of cases, you don't need to do that. SQLMAP will automatically try to do it for itself. Also, there is one neat thing inside where if something is really fast, so if the web application is really fast, your network connection is really fast, it will say, okay, maybe I could try to optimize the delay value. So instead of using the 5-second delay, which is by default, it will say, okay, due to the good response time, I will automatically decrease that same value to the value of 1. So it automatically, I would say, crunches that same bell curve to help you, and instead of waiting for 5 seconds for the true response, you're waiting for only 1 second. Finding query field count. So in case of union-based SQL injection, as said, is the fastest one, but you have to, I would say, tame it. You have to master it to properly, I would say, exploit it. So first, you have to find the proper number of columns inside the original statement. So if, for example, you have the select ID name, ID, username, password from users in the original statement, then you know that the original statement had only 3 columns. Problem is that from the perspective of the SQLMAP or the attacker, you don't know that by heart. So you have to poke around. And the fastest way how to poke around is the usage of the order by clause. Order by clause is really neat because you can deduce the number of columns in least possible requests based on, for example, in our case, on the binary search. So we are using the adapted binary search, and we are going to all those, I would say, field counts, which could be at the other end, and we try to, I would say, deduce what should be the outcome of the response. Just to show you, because this is highly abstract. So if you can see here, this is the simple SQL injection. So here we are trying to find out the number of columns, And now just to show you the principles of the order by, if you put some huge number here, like the order 5, order 100s, you'll get something like this, either the SQL error or you won't get any kind of response in return. But if you put something that is equal to column number or less, you'll get some proper results. So SQLMAP is is doing is using it, or I would say abusing it, to find the proper value by doing this same kind of poking. So you've seen here that the 4 provoked the error, but in this case 3 didn't provoke, so we can deduce that this case the other end has only 3 columns. And now just to show you why it matters. It matters because if it fails, so in this case SQLMAP failed with a couple of requests, it said, okay, order by is not usable. I'll try to brute force the number of columns. And now you can see lots and lots and lots of payloads which will be sent to the other end. But SQLMAP also uses one heuristics here. So in lots of cases you won't be able to, I would say, abuse each of those columns here. So in some cases you'll be able to abuse only this column, first column, or the second column. It all depends on the results of the original request. I don't have it. So if the original request, for example, had only second column in result, you should really poke around and see, okay, this second column should be usable. But there is a neat trick that we try to use. So we try to use nulls inside of different combinations of the column values. And the key thing is that in case of 3 columns, this one will result with something which will stick out, or I would say it will look like the original web response more than compared to the others. And now just to show you, because it's highly abstract. So here you can see this was some error. But in this case you have something that looks like the original response. So now when you compare all those responses here, one which is sticking out should be the proper column count. So in this case, this one was sticking out. We said, okay, you have 3 columns. Boolean inference. How much time do you have? Boolean inference. So we had lots of user tickets which said, okay, why don't you use the binary extraction? So why don't you extract bit by bit by using the regular AND operations? And we said, no, we are using something faster. And that faster thing is called Boolean inference. And why is it, I would say, important to mention here? Because, for example, imagine that you have a table of ASCII values, printable ASCII values, and you just need to focus on those values inside that same table. So instead of extracting all 8 bits per character, you are doing the binary search inside that same table. So in this case, if we started with the, for example, uppercase ASCII letters, so instead of extracting all those zeros at the start and going through the bits, we are doing the greater than comparison. So in this case, original table of the expected values was the uppercase ASCII letters, and we said, okay, in the middle there is M. Is the current value bigger than M? If it's true, we split this same table in half and say, okay, this upper part is something having our expected response. Then we continue on, and we split, do all those splits inside the expected table values, and we are left with the 2 or 1 values. We deduce, okay, now we can do anything, but to conclude, in this case, that same response was not greater. Okay, this is an error in slide. There should be a P here, and if it's not greater than P, it's false. Then we can deduce this. It's not greater than P, and you have only this table with the P and R. We can deduce, okay, the one that is being left is the R. So based on this binary search principle, we can do the, I would say, logarithmic complexity retrieval of the data from the other end. So in majority of cases,